It's Rucha.
Rucha, I think, can we start now?
Hello, am I audible?
Yeah, Rucha, I think we should start. Let others join, so it's fine. We have numbers now.
Okay. Good evening, everyone. The series invites speakers who are engaged with particular aspects of architectural design and production in their practice to throw light on topics that are central to the architectural profession, but less discussed or theorized within academia. This year, the thematic focus for the series is architectural detailing in the realm of theory and practice. Robert Verrijt is from the Netherlands, where he received his master's in architecture from TU Delft. His master's thesis was awarded the second prize in the Dutch Archiprex 2004. After working briefly in the Netherlands, he moved to Sri Lanka, where he joined the office of Channa Daswat and had an opportunity to get an insider's perspective on the work of Jeffrey Bauer. In 2006, he moved to Mumbai to start Architecture Bureau. We are glad to have you here, sir. Thank you.
You're welcome. And I'm really looking forward to this. We have about 25 students here in the group. And before I start, you can all see me. And I would really appreciate if I can also see you. So if it's possible, I would.
Yeah, I think some of you can sort of open your videos.
Well, of course, if you can't for some reason, please feel free. But I would like to get this to be a little bit interactive. Today, I'm going to have a lecture that I've never done before. It's all improvised. I have selected a few projects of our studio together and looked in our library of architectural details. And I'm going to just start talking about it. I have I think about 7 or 8 projects in this presentation. And for each project, I'll share a few details. I'll first show you a little bit of context about these projects, but I want to try and really focus on the detailing itself. So I have no introduction, I have no sort of general talk about our work. I will just talk about projects and detailing. And I hope that after every project, we can have a small discussion and question-answer session. Instead of you having to sort of save up your questions all the way till the end, we can do it after every project. So you can really ask specific questions. And then I hope I can answer them, because some of these projects are 10 years old and may not remember what we did and why we did it. But who knows, right? So it's a bit of an experiment and a test. You can test me, see if I still know what we did and why we did it. So the first project that I'll talk about is the Magic Bus Learning Pavilion. And this was one of our first projects, actually the first ever project that we built. When we started out in 2006, Shefali, my partner, she had worked in the beginning of her professional career at the architecture office of Ram Rotra. And there she had worked on the Magic Bus campus. And this campus was this campus design, which we made a second master plan, was a sort of a continuation of what Ram Rotra set out in the beginning. We designed several things in this campus, but the project that I'll talk about today is the Learning Pavilion. And this is really, very simply said, a building that is making it more comfortable and easier for all the students who come here to this campus to learn about teamwork and learn about how do you actually interact with each other, and how do you interact with nature. This campus is meant for children from unprivileged backgrounds, for children who, for example, live in the slums in Mumbai, who really don't have any place to play, no place to play at all, let alone place to play in the outdoors, in nature. And while there's a forest and there's a big soccer field, many months of the year in this climate in Karjat, it's so unforgiving. It's either rains tremendously or it's so hot that you can't really, like, it's very difficult to play outside any sports. So this pavilion is meant to create some kind of climatic shield to still allow play during those difficult months. And we placed this pavilion strategically on a site, on the side of this campus, and demarcating the dotted red line, on a place where there are three elements coming together, three landscape elements coming together. There's a hill, there's like a large lawn, a soccer field, and there is a stream. And this pavilion is placed right where those three elements are coming together. And in fact, it sort of straddles across this stream. It connects on one side, on the left side, to a hill. On the other side, the right side, is the soccer field. And it really covers the stream. And there are several ways to sort of get in and around this building. One, for example, is through this log bridge on the left side, and then you have to climb the hill and then you go up. Another way is to enter from the... Can you see my mouse, by the way? On the screen? Yeah?
Yes.
Yes. On ground level here. You can walk up to this deck from a jungle bridge, like a ropes bridge. And there's a ladder that takes you up to this level as well. And so this building, it is ground +1, 2 floors. But in the submission drawings, we had some big issue, because when the government officials saw the drawings, they realized there were 2 floors, but there were actually no staircases. So we had to kind of explain that, yeah, we don't want a staircase and we don't need a staircase, because the landscape itself is a staircase. And this is this building is a challenge course extended into a building. There are other ropes courses and Jacob's ladders in this campus as well. The zip line is there, and this is sort of that extension. So you have this log bridge that the kids walk over, and this is, of course, these small little elements are just aspects to teach children to overcome how they can overcome their boundaries, because everyone may have different levels of expectation and different levels of how they, are adventurous or overcome their fears of things that they haven't done before. And this is one of those. You see, it's a very simple, straightforward structure with columns and a sloping plexiglass roof. There's a kayak storage below, and then there's a deck on top where they can play games. And here you see this ladder. And then here you see the ropes bridge on which these children, these girls are standing, and they're cheering their fellow students to climb the Jacob's ladder on top. Here, if we plan, you see these different landscape elements coming together, and an axonometric that we generally make often in our practice to really explain all the different spatial programs and elements of a project and how it relates to a landscape. And here you have a cross section through the building, but then with detailed fragments marked of the overall section where we highlighted certain materials. And this is across, you see here a detail of the Jacob's ladder, the climbing element with the logs. And here you see a detail of the jungle bridge, and then the wires that suspend that jungle bridge, and then we've got the steel structure above. Now, a rope bridge, we never designed it. We didn't know how to design it. Our structure engineer didn't know how to design it. So we practically had to, to visit rope bridges and to research how they are made. We realized that we needed some kind of ropes underneath those planks, and they needed to be suspended from ropes above, from the roof. But when we started making models, and we had discussions with several experts, we also realized that we needed some kind of ropes, these diagonal ones, to prevent the bridge from swaying left to right. And then here you see a detail, and then I can probably zoom into this as well. Yeah. So you see here the web of the steel member, and there's a bolt with an adjustable fitting that allows you to tighten the SS hanger. That's a rope, a steel wire. You see how it's connected here on the top. And then there's also an additional plate, right? This plate actually stiffens the web of that the bottom member of the steel beam to prevent this from sagging over time. We actually, there's in India, there's not really any manufacturer you can go to and say, I want to order a rope bridge. So we went to the Mumbai port, and we then spoke to several sea shipping companies, because of course they are very much used to working with steel ropes and with fixtures, and we really talked to them about how you can actually connect all these things together. So this hanger goes down, and then it is at the bottom with a wire holder. It is holding a T-section. And that T-section then connects the wires on the diagonal wires, the straight one, with the wires on the right side, and it becomes this bridge. And then across in the cross direction, you have several wires that are actually running in the length. And on top of that wire, there's an extra timber block. And then on top of that is the actual boardwalk, this timber plank that you see. But this extra block here below is really because of course, this is not a static thing, this bridge. It keeps moving. Kids jump up and down. And the wire is steel, and it has a sort of a rough surface. And over time, it will start rubbing off on the wood. And that wood will start, eroding in a way. So that extra thickness is really there to make sure that the planks themselves never start eroding. Now, a bridge like this also needs to be maintained, and it also needs, 1 second. It also needs to be checked every year to make sure that the fittings are still all right, and that they haven't corroded or they haven't loosened. These are some of the fittings that we used in this bridge construction. And then you see here the project again in use, and you see more detail of that connection at the bottom. And you see here at the bottom of that bridge also that rope below the thickened timber members. And yeah, this is, for us, this project, if there was any detail that was important from an architectural point of view, it was this detail, because this building is all about sort of connecting and connecting two elements of a landscape, a hill, a plateau, and you're covering this nala, this stream that runs below this deck. And yeah, the bridge physically does that. So how can you sort of make this a very light, easy on the eye sort of element that travels across these two directions? But there's another detail in this project that we found important to show. Yes, there's a deck, and the deck is also the roof of a kayak stand. And of course, this project is, has to be low budget. This is for an NGO. So how could we make a sort of a mesh screen that kind of locks up these kayaks so that they can be safely kept? You can see here another river here behind. This is the main river. There's no fencing around this campus, so anyone from the village around can walk through the river. It's very shallow, and they can take canoes if they would want to. So the only security that we made was through this fence. A very simple L frame with a mesh that is fitted in between. So you see here in the detail an L frame and then a mesh that's fitted onto that. Now that was not an easy detail either, because that mesh that we bought actually came on rolls, and when you started unrolling it, it started all sort of bubbling, right? So often things don't work out that well, or they become very complicated and time-consuming to correct. This was a learning. One of our first learnings, in a way, in building such a project is that from then onwards, we started making mock-ups when we were doing things like this, things that we hadn't done before and things that had to be tested out, so that we wouldn't have to correct each element that was made before you actually saw it inside. So that's the first project, and does anybody have any questions about this?
Does anyone wants to ask any question? Do you have any questions? We don't want to ask how the bridge is stabilized with vertical cable and a diagonal cable. On the other direction, what happens? Okay, Robert, I think then we should move ahead.
Yeah, we should move.
Yeah.
So do save up your question then, but the next project I would definitely want a question from you. Yeah, this is next project is to repair an house. This is actually built just on the other side of the hill of this previous project. And now you see a little bit of the context of where this is actually located. This is the starting of the Konkan mountain range, right? Just the start of where you have the valley, the coastline where Mumbai is. You drive up to the east, and then these are the first hills that you see. This is the Mataram mountain range, an iconic mountain. And then there's a lake, and you see that all these sort of rivers and streams find their way down, eventually leading to the Bombay Bay. And then it passes this site. Well, you see the roof of the learning pavilion just over there behind the trees. This is early morning in the winter, when the river that fluctuates in height is sort of giving off steam. And again, this is a site where for us it was very important, very small site, just about an acre. Our challenge was really that on this small site of 1 acre, how do you make one feel as if you're in a much larger landscape? And the struggle with these kind of homes, is a weekend home, right, is that often they become very isolated elements cut off from the surrounding. They become little enclaves. They become a little schizophrenic in a way, right? Little islands with their own culture and their own set of rules within something that's very alien to them. Around this is all agriculture or like neglected sort of forest land in Verrijt. And homes that are built in this kind of environment are often really cut off, and they also become then sort of these fortresses. And if you are living here for generations and you have a land bought by one of your fellow farmers and somebody from the city builds a house there, it feels as if somebody is sort of invading your land, right? Your ancestral land. And there's a tension that is created there. And this is only aggravated by sort of this fencing off and walling off of sites. And when we started this project, we had conversations with the clients, and we came to a conclusion that it was much better to have a much gentler approach and a much more open approach. A sort of an approach where you don't defend, but you allow movement across, and you also you're showing that you're not afraid. You're not afraid of what may be stolen or what will happen to your property. So there's a sort of a mutual respect that you're building, and you're building that mutual respect by building a home that is also respectful of its environment and doesn't shout, "Here I am," right? And so this house is sort of it's not built on top of this hill. We could have done that. It would have then probably had a better view, but it's built just with the top of the roof in line with the hilltop. And in this way, the house with its profile settles in the contour of the landscape. It's a little bit uphill. It's almost like a chameleon and a riparian animal that sort of hides behind the grasses and the bushes, sort of eyeing on its prey of its surrounding, but very gently, right? And it's there to almost be invisible. And that's what, in a way, the story of the detailing of this house is as well. Here a photograph from the top of the site, from the top of the hill, and you're looking down, and what you see is 2 courtyards, and then just a piece of grass that's sort of the roof of the house that covers the roof, and that keeps the building cool as well, because the earth is, of course, insulating. And this kind of shows that then the house becomes barely visible from the top as well. And here you see the reflection of the house on the water. there's a road that sort of leads up to the mid-level just below the house. There's a pool that just about sticks out here with this corner. And then the rest of the house is a thin slab. It's a 100 mm slab on the edge. The actual roof with the green roof is set back so that you see a very thin edge only, and you don't see a thick sort of beam that behind which the earth is sort of retained. And then there's a deck that wraps around this building. It is a deck that acts as a veranda. Of course, the roof is also cantilevered so that it gives shades and it protects the inside from rains. And then below that, you have actually sets of screens that are made out of bamboo that are hanging off that roof. You see again an axonometric. We have pulled out the building from the ground, from the hilltop, out of that black sort of excavated portion here. And then half of the building is sort of sliced and then rotated around the axis so that you can see really how it relates to the landscape. The top of the hill with this red line, you see the back, there's a courtyard with a rock cut staircase that runs through the kitchen, through the dining room, down the staircase, over the pool, and then further down into the landscape. And then these lighter elements like the decks and the windows are pulled out of that axonometric again. Now here you see, pretty much all the materials that are in this project. You see a stone wall. This is a limestone. Then you see this thin concrete edge here with a bigger beam that retains the soil above. You see a steel beam here at the bottom that you see in section as well. In the section you see also that stone wall behind there. You see the bamboo screen that hangs from the roof and is connected to the beam on the side here. You can zoom into. So you see that this deck here with the timber planks, this deck is not supported on the ground, and that's really to make it look and seem as light as possible. This beam is actually suspended. It's suspended through a rod. This rod that you see here, which is there fitted on top in the slab. And then to the side of the beam, there's a plate, and that plate, a vertical plate. That vertical plate has a hole in it, and that hole has a rod in it, and the rod has small little pipes, and between the pipes are actually the bamboos that are sort of arranged like a chain. So let me see if I can zoom into that as well. So you see here a little bit that plate, right, that vertical plate. And you see there's a rod with the pipes. The pipes are there to actually keep the distance between the bamboos. And wherever that plate is, these pipes are again, it's halved. So you see it sort of separates the pipe again. So to keep the bamboo screen in place. There's a plate here and another plate over there. And then you see this on top, it's suspended from the slab. Now, we didn't actually know in advance exactly where we were going to have those plates suspended. So what we've done is we've actually cast a whole steel strip in the slab so that we later could weld these vertical plates in any position along this slab. It allowed us to to be flexible there. Yeah, you can actually then see also here on top that plate that is cast in the slab. The drip mold, which is of course very important, because otherwise you get streaks of dirt along the inside of the slab. This allows the water to drop down before it hits the bamboo. And here images from the other side. And here what I want to sort of show, what you see much more clearly, is these suspension rods over here and here that are holding up the veranda. You see it here once more. You see that the bamboo has actually three of these rods running through. One is at the bottom, straight, and it also has the ability to even move after installation and warp. So this keeps the bamboos in place over that full length, which is, I think, 0.9 meters, if I remember correctly. And then, of course, at the top as well, where the ends are connected together and where it's suspended from. Now here on the left, you see a detail of the windows. The windows that we made for the previous project in steel with a steel mesh inside. Here we, for the first time in our projects, have used window frames made out of steel with glass infill. And in the past, I think even SAP still has windows, steel windows with glass, but not anymore. Does it still have it? Yeah. So it's not very generally used, but what we really wanted to emphasize was a sort of a mesh of glass and steel around this, around the side of the house that faces the river. And the only way to do that as thin and elegant as possible was with steel members. And in many parts of the world, you can again order them off the shelf. In India, you can't. At least I don't know of it. If anybody does, I would love to hear it. So we had to make it ourselves, and we had to work with a fabricator. We use very simple L angles. Usually they are more like more complicated profiles, but we use L angles that we cut to size to make it fit to the right size. So the beading of a frame is 25 by 25. And then the outer frame, the fixed frame, is 40 by 30. And then there's a fixed frame outside of that. It's again 40 by 30. But to make a window that is also sealed, you need to also make sure there are overlaps and there are no gaps in the windows. So there are additional elements, like for example here at the bottom, that prevents water from going in from outside into this floor. Little beads that are connected to the steel that are creating an overlap. You see here, this from the inside. You see that the openable doors are swung to the outside, and then there's another set of doors that are opening up to the inside, which is a mosquito mesh. So it allows you to keep the The windows open, the glass windows open, but close the mosquito meshes so that you still have ventilation. This is a quick video of how that actually functions.
This is the master bedroom.
Yeah, so she's very enthusiastic. You can see opening and closing these windows and the mosquito meshes. So now, when you have such a thin frame of 25 mm, you cannot fit normal hardware on it anymore. So you have to then start customizing this hardware. So these are, for example, bolts that lock the doors in place. You see a little hook on which they are resting when the doors are open, and then they can like be lifted up and then turn around, and then they go into the floor to lock them in place. These kind of steel doors, they would generally rust if you don't treat them well. So what we've actually done here is we've hot dip galvanized them, which means it's a process that, unlike painting, which is really a coat on top of steel that can peel off and it can deteriorate. And once paint starts peeling off, or it has a small little hole in the paint layer, the steel with the air that it's exposed to starts oxidizing, and then it starts spreading beneath the paint layer, and then before you know it, all steel is in a way corroding. With galvanizing, hot dip galvanizing, this is not the case. Zinc, this hot zinc bath that the steel members are being put into, it sort of merges with the outside layer of the steel and creates a layer that is permanently fixed to the steel. And even if it gets damaged, the zinc starts sort of healing back once it's damaged. It's a much more durable way of treating the steel. And in this project, we left it exposed because we really liked it, the look as well. Not everywhere this was successful. So in some places, the process of hot dip galvanizing didn't work. It got damaged too much. Like if a really large part of that galvanizing layer gets removed, then it doesn't heal back. In places like this, like hinges, we couldn't hot dip galvanize it, and then we had to improvise in a way with a zinc paint, which is eventually a paint, so it can still come off. Yeah, it's not the most ideal solution. We were also very worried about how it looked eventually, because you see it as a difference as well in the finishing of the part that is sprayed versus the part that's hot dip galvanized. And then you see here a bathroom where you see a different kind of window. This is facing the view again, so we want to make sure that we could look over the windows to the outside while you even would shower. But we also want to make sure we had the possibility to ventilate it. So here we've used a system which is like a bit of a casement stay, in a way, a bracket, a friction hinge that opens up. And then between the bathroom and the master bedroom, there's cabinetry that is inbuilt that doesn't really have a brick wall. It's just cabinetry that separates the two spaces. So any questions about these details? for the making, or any mistakes, or any questions about how the process of making of this was.
Hi. All the details are very clear in terms of understanding. But when you insert a building in the terrain,
We can't hear you, Vivek. I can't hear you.
hello, hello.
Yeah, you're audible.
Yeah. So
Right now. Yeah.
when you try
Maybe
to
you try and turn off or remove your headphones. Is that possible?
hello, when you insert your building in the terrain,
Somehow still doesn't work. Can anybody else hear him?
Yeah, we can hear. We can hear you.
Oh,
so when you insert your building,
Wait.
My mistake. I have my sound off. My apologies. Yeah, ask me again.
my question is regarding when you insert your building in the terrain. So so what kind of challenges you face for the rainwaters and as well as the foundation, because you are responding the terrain at the ground level. So what are the challenges you face during that?
Yeah, it's a huge challenge. And in a way also a little contradictory, right? You're trying to say that you're building a house that sort of engulfed with nature and really responds to landscape. But on the other hand, to really allow this to happen, you have to dig into the earth quite violently, right? Remove rocks. I'm not sure if we did any blasting. I don't think we did, but potentially you would have to. And then you also have to make sure that when you build a house inside the earth, it doesn't shift along the rock surface. So you have to build retaining walls on the backside. And then in our case, we made it even more complex because we want to have the landscape go over the house. So then you need to create a concrete slab, and then you may have to waterproof that because you wouldn't want this entire roof to become soggy and wet and damp over time. So challenge one was the foundation, the retaining walls, which had to become quite heavy. Challenge two is then the water that actually flows down the hill doesn't necessarily go over the roof and then you can take it away. It goes also underneath the foundation and then it tries to find a way up, right? Hydrostatic pressure. It actually water in the monsoons, it becomes one big bath, this place where you're building, one big bath, and the water tries to come up not just from the top, from all places, from the bottom as well. So we had to wrap around the foundation and the bottom of the footings also with waterproofing membranes. And then you have to make sure that these waterproofing membranes are punctured during the construction. You imagine people are having big equipment and you have to fill earth back, and then with that, maybe people are with shovels are hitting their walls. So then there's a geotextile that prevents, that protects that waterproofing membrane. And then after that, when the earth is pushed back, then you start growing trees, and those trees have branches, and they will try and grow into the wall, right? So that needs to be protected with the same geotextile. And then you need to be able to take away the water that tries to come, underneath the foundation. So actually, at the bottom of the foundation, I can make a quick drawing. Since we are, can I do a quick drawing? Let me see if I have the possibility here.
You can annotate.
Yeah, I was trying to find my annotate button now. The bottom is somewhere, but where is it on the screen? Usually I can find it. This time I cannot find it. No, I can't find it now. So at the bottom of the foundation, there's a pipe, and the pipe is perforated, there are holes drilled into it, and then it's wrapped around with a geotextile again. So the geotextile is there to prevent water from mud from entering that pipe. It does allow water to go through, and then the pipe is then connected eventually to the bottom of the site, to the bottom of the splint on the outside, where it can dissipate.
Yeah, thank you.
Yeah, the point is, in a way, like what I try to explain is, it's intensive, right? You have to do a lot of work, a lot of architectural work, a lot of construction work to eventually allow a building that sort of hides, that's embedded in landscape. But eventually it also does make sure that nature can grow back and can grow over and around the building. And eventually, while this sort of temporary disturbance is there of the surrounding, eventually long lasting, over a long time, you have a building that is much more nature centered in a way.
Yeah, anyone else?
Yes, I have a question. In this very particular detail where you have used wood in between the metal and the slab, and there is a part of wood which goes into the slab. So was there a provision kept for that? And if not, then was it done later after the construction? And adding to that, when we use 3 of such materials, very different materials, so is it helping in the expansion contraction, or is it creating more difficulties for it?
Yeah, very good question. You're talking about this piece, right?
Yes.
Yeah. Thank God that we provided for this piece. If not, we would have had a huge problem. The concrete slab that was cast on top of these are steel columns actually, right? So there's a concrete slab here with beams, upstand beams that retains the earth. But that concrete slab is not straight. It's not cast straight. There's actually about 25 mm difference between one side and the other side. And 25 mm is just that sort of thing, that dimension where you can not anymore tell the contractor to demolish it and rebuild it. Right? If it's 50 mm, you can say this is ridiculous. This is not acceptable. You have to redo it. And 5 mm would be ideal, right? 0 mm is not possible. Nobody can do it. 5 mm is ideal. 10 mm is good, but 25 mm is a bit too much. Because if you have 25 mm, then all these windows would have different heights, right? And we were hoping that we didn't need it, but we did put it. So we have a little cavity in the concrete before we cast the slab. We actually put a formwork, and then we put a little strip of timber as a false formwork, which we later removed, which of course got stuck. So difficult to remove it. We learned you better make it a little wedge shape so that it's easier to remove, and put oil, of course, on top. So eventually the contract had to burn it out. So this cavity allowed us to put a little timber block inside, and then of course a timber block can be very easily changed in height, right? You can make the top in a slope, and the bottom you can make perfectly straight. And timber is the most easy material to make a straight line and to refine. Steel is also difficult because if you've made a mistake of 5 or 10 mm, then you have to sort of cut the steel and weld it back. You'll get an ugly joint, and it doesn't come out as nice anymore. So it's better not to make the adjustments in the steel. We could make the adjustment in the margin level in that timber piece. We didn't really need it for thermal expansion. That's what you also asked. Although there is, of course, also a gap here. I'll try and show you that. So if there's a thermal expansion of the steel, it could expand to the top. There's a small gap there. That allows it to increase in height. But you know, the steel window is protected from the overhang from the sun, so it doesn't have a lot of heat gain. So I wouldn't expect this to really expand. Yeah, I hope that answered your question.
Yes.
Yeah, Tarun.
Hello. Hi, sir. I'm actually not from SEP, but I have a question. The details here are like really detailed, and you can't really do it if you have not planned before. So all of the things have to be ready before you start construction. So I was, how long did you take to like figure out this entire project? Like just to know that the timeline of how long you had taken to detail it, all of this, just a curiosity.
I think our design process was 1.5 years, if I remember correctly. But it wasn't because of this detailing, actually. It was a design process that was long. It was a stop and start design process where we had several iterations of requirements from the client, smaller, bigger house, and small again, and bigger, and then also waiting for waiting for the local panchayat approvals. Yeah, you're right. All this has to be planned before, right? If you don't plan that cavity in the shaft, and you have a mistake, and you won't be able to rectify it again.
Yeah. Thank you, sir.
Anyone else? Maybe I can ask a couple of questions for the students. One thing you need to ask is that, let's say, a very interesting detail of one angle sections overlap with another angle sections, because earlier Z sections were sort of made, and that's what SEPT has. But this is again a very interesting way to deal with two sections, okay? Because one of them acts like a beading putty, okay? If you treat it like a timber section. So one of the question would be that how is that outer angle section, which is 25 by 25, fixed onto the main angle section, which is the frame of that opening?
Yeah, that's right. Do you have a picture? Yeah, you see also here that this is our improvisation to the Z section, right? These beading putties that are on or between frames, because typically a Z section would allow you to have this piece to create the overlap with the fixed frame. But the question that you actually had is that inner frame, and you see, I think here you see the hole. So it's actually, yeah, let me see if I can move.
So it's a grub screw.
It's a screw that, yeah, you see the screw hole here and here and here. So that's how they are connected to the side, because you of course can't screw into the window. You have to screw vertically.
Yeah. Now the second question that again you need to think about is that if you look at the mesh, and the size of the mesh. And if you look at the beading putty of the mesh, it is a plate. Okay. And generally plates are sort of slightly difficult to handle in in steel.
Yeah.
So one question that comes is that, generally how the mesh is done, sometimes it is stiffened by rolling a plate. Okay, and then you sort of screw it. But in this case, if you look at it's very light, it uses plate. So how is it fixed? Is it directly grub screwed into that section?
I can show you, I think, here in the picture. I can't zoom in more.
Yeah, it's there. It's there. Yeah,
Right?
yeah, it's
That's
there.
how it's screwed. Yeah,
So it is fixed.
it's fixed. This is fixed horizontally.
Yeah.
This way through the mesh, which is also making it difficult, because then if you have to cut the mesh, then maybe it gets damaged there, and then it starts potentially those fine little lines of the mesh may get damaged, right?
Yeah, but it's also difficult. We need to see, because at the corner conditions, if you have got, let's say, plates which are sort of folding it, let's say you're folding the mesh in the plate and doing it, in the corner conditions becomes tricky. So what I'm just trying to point out to all of you is that once a detail is shown in 2-dimensional, you need to think in 3-dimensional in order to address. So connect back from the back. So the third question again is that if you look at the outer section which was shown, the channel section was being lifted from the slab using a pipe. Outside, Robert, that section where you were showing the outer layer with the bamboo screen.
Yeah, this one.
Yeah. So that section, if you remember, the questions immediately starts coming. He said that the channel section is resting on the pipe. Okay. So obviously there are a lot of questions that starts emerging about its stability. So is it intermediate resting, but there are members on the corners which are coming, which have a support, or is there some intermediate support for the channel which you can't see in the section? Okay. So there are multiple questions at least which starts coming. So the drawings are clear, very clear, but sometimes it requires a little more drawing to be more clear about connections. That's so Robert, that you will have to unravel that pipe in relationship to the stability of the channel section.
You're talking about this pipe, right?
No, the hanging one. You're hanging the channel. No, not this. The structural one. The structural one.
Oh, okay. Yeah. This.
Yeah, that one.
Oh, yeah. Yeah. Let me. Yeah. And here probably is one of these moments where I'll be like, okay, how was this done? Because our drawing is showing just a line.
Yeah, that one.
It just shows this, right? And there's nothing there. And I do remember we had a drawing for this, but we've basically, we've had to embed a pipe with a female threaded screw inside the concrete, and that pipe is connected inside the slab with reinforcement bars.
So now from sequence of construction point of view, it's amazing, no? Because see, the thing is, if you look at the bamboo screens, there is a plate which is running, which was sort of thought about, okay? Similarly, the precisions of getting these two rods and because it connects to the reinforcement. So all of these is sort of a great challenge, no? Because constructional tolerance is something quite interesting, and how has somebody thought about it sequentially to anticipate that where all the errors would be there, and how do you then negotiate the error? So so for example, the sort of niche in the timber in the inner section, in the slab in the inside, And then now you start seeing this and you start seeing that vertical member.
Yes.
So
this female threaded joint has to be exactly in this right place. If it's a bit to the left or a bit to the right, yeah, the rod will not be straight, right? And now I don't know exactly in this picture whether the bamboo was not straight or the rod was not straight, but you can see actually that they are not exactly in the same plane.
yeah, and yeah, so we need to learn that, because see, when we are doing this, in which direction the tolerance is and which direction the tolerance is not.
Yeah, exactly. And then also, you know, you can't play around too much at the bottom because you have the railing. So if you would have to move the bottom joints of that rod to the left, it would hit the railing, right? To the right, you could still shift it a bit, because you see in this drawing that the rod is here fixed to the back of the beam, and you could keep a little smaller, a little bigger gap than required. In the other direction, you can play around wherever you are placing that rod, right, along the beam. So there you are allowed to have some tolerance, but not really in this sort of left to right condition. And so I do know that one of these rods is not perfectly aligned. I remember being really annoyed with that.
Yeah, tolerances are something so difficult in construction. The bamboo is hollow, no? Or is it solid bamboo?
It's hollow.
It's hollow. It's behaving all right in terms of cracking?
In terms of cracking, it's behaving. It's been behaving very well. We did several different kinds of coats over the years on it. Initially, we did, I think, an oil, if I remember correctly, and the oil worked well, but didn't work well in the monsoons. So after the monsoons, you would have a lot of molds attaching to the bamboo.
Yeah.
Then a year later, we did bamboo. We did a varnish over the bamboo. Then we used the wrong varnish because the varnish became started melting in the hot season.
Yeah.
So it became a little sticky, which then attracted lots of little, the little bugs and little dust that got stuck into the varnish, which then of course becomes nurturing for molds over time. So then the year after we had to again strip that down, and then we went back to oiling.
Okay.
But
it is Dendrocalamus strictus or Stockside or some other species?
Oh, I don't remember. I don't remember. I do know that it comes from Karnataka.
Okay, then it won't be any of the two. Okay.
Yeah. This was treated through a fumigation process.
Okay.
Yeah, but you see later in another project also that since then we've avoided using bamboo on an exterior surface. We've continued using bamboo, but we've started being more hesitant with proposing it on external surfaces.
Yeah, it's okay. That we'll discuss later.
Yeah, maybe you have some tips. Okay, so shall I continue?
Yeah, please.
Okay, House on the Stream is a project of a very different kind in comparison to the riparian house. This is a house that is much more sculptural. and it's much more expressive in a way. This house is about sort of connecting two parts of a site that are divided by a stream, by a natural stream that runs through it in the monsoon. And in the dry period, it's sort of a dry river pebble bed. And what we did here is our strategy was to sort of create almost border-like sculptural elements, cantilevering off the edge of a stream to emphasize in a way the connection with the landscape, to emphasize how it could sort of settle in by sort of maybe contradictorily lifting it off the ground on all these corners, on these edges of the building. It sort of feels much more part of the landscape. Here the exploded axonometric is in two parts: the main house and the annex, which has a master bedroom, is both extruded, and then again they're folded out, so you can see the inside of the section of this house. And you see how we're kind of playing with volumes that are volumes where there's a very strong difference between the inside volume and the outside volume, emphasizing in a way what we call what is termed a poché, which is the space between the inside envelope and the outside envelope. And that's also emphasized in the materialization, right? So the inside envelope is all white, it's all white painted surfaces, and the outside is this raw concrete. It's much more rough, solid and monolithic material that encompasses the entire building. You see the section, the middle section here with that emphasis of a sloping roof. A sloping roof that sort of expands out into the landscape through different arms of the building. They're almost like an insect sort of stretching out between different existing trees. And then an inside surface where in some places we just a plain flat ceiling, and then in the center of the house it sort of expands up and it reaches out and it opens up. This is happening in the plan as well, this expansion and contraction and shifting of accesses across the plan to create a very sort of dynamic relationship with the land. And that's what you see in this picture as well, right? You see an axis towards the courtyard, you see an axis, diagonal axis across the main kitchen here, but also a linear axis from dining to kitchen to a living room, which is raised a little bit, and then the vertical axis of this sort of pyramid shape on top. And then here there's a cross section throughout the building, throughout the length of the building. Let me just show you. That is this one here. And then spot sections drawn to it. So we have a foundation. There's a very bad soil in this place of Alibag, which is called black cotton soil, which is a soil that expands and contracts depending on the seasons, depending on how wet the soil is. And you have to actually go down with your footings, with your foundation below that soil layer, so that the building doesn't settle, doesn't settle one side of the building in a different way. But then on top of that, you of course also have this stream that runs through the building in a way. And the stream is now nice and gentle, but it also can become a very violent stream that fills up almost touching this bridge. So there's an enormous amount of water that's rushing down the mountains and that is pushing against these walls pushing against the concrete, and that concrete therefore is extra heavy, like being placed on the bottom strata, on the stable strata. So that's what you see here in the section. You see these concrete walls that are rising up, and then you see this slab that sort of folds along with the profile of the roof. You see some beams that are kind of hidden, and there's actually a false ceiling that creates the level differences between inside and outside. So this is not a building like the structuralists, like Herzberger, or like also Doshi would of course build at Sept, where the structure is exposed, is visible. No, this is actually a building that in a way looks very modern, but is in the tradition of the Baroque architecture, right? Where the architecture is about space and about expression of that space, and it's not about the expression of structure, at least not on the inside. Yeah, and in a way, it's very simple, right? It's just plasterboard on an framing that is sort of hiding behind all this whiteness here. But still, it's yeah, you feel when you're in that space as if it's sculpted out, as if you're walking into the inside of a boulder, into a cave. But then expands, and then it lifts up. There's a skylight which sort of floods the space below, and of course the skylight is the most risky thing that you can do, because it always leaks, right? At least as long as you've not detailed this properly. But what we did to prevent the risk of leaking is, one, that concrete slab that folds up, it creates an upstand. And then two is we didn't create a skylight where the glass is vertical or horizontal. The glass is only vertical. This also helps because, you know, if you place a glass horizontal in this kind of climate, in the dry season, it doesn't rain, so a lot of dust gets collected on the glass. You have bird droppings, leaves that fall down the roof, and within a few days, a glass that you would have freshly cleaned is dirty again. It become a maintenance nightmare. So it's only vertical, so that it doesn't allow anything to settle on top of it. Now let me show you the light effects of the skylight. It is facing south, which you would say, well, this heats up a lot, but it's facing just south with such a little, at such a proportion that moment of direct light through the glass is very limited. It's limited to half an hour to an hour a day, which creates this amazingly dramatic effect throughout that moment, throughout that day moment, a different kind of light that comes inside the space, and these shafts that are running along it. But it is not to such an extent that you need to be extremely worried about the kind of heat gain through direct glass. And then, of course, the leaking component. We initially wanted to do this as light as possible in steel, but then we were worried about corrosion, so we eventually said, okay, let's do this in timber. And here we are. The roof structure is a timber frame, a sort of just a boxing of different material, different frame timber boxes. There's a gypsum board at the bottom and then a ply sheet above. Then this is filled with insulation. Of course, there's insulation on the roof itself, otherwise that concrete slab would heat up a lot. There's a small gap between the insulation and the plywood to prevent dampness or moisture build up. And then that is covered with PVC membrane. Then there's an L section that creates a drip mold that makes sure that the water that falls over this edge doesn't fall directly on the glass. And you see here a timber frame and a timber frame again. And this timber frame this is actually more schematic drawing. Eventually, this timber frame also overlaps with that upstand, because otherwise you would have water that sort of seeps through the gap that would eventually be existing here through expansion and contraction. There's also a small ventilation gap, not in this section, but in the other section. So it actually allows the hot air that does sort of accumulate at the top of the skylight to escape from the top. Going back to this, yeah. Everywhere in this building, we either have only floor-to-ceiling windows, sliding windows, or these kind of doors that are floor-to-ceiling and wall-to-wall. But in some special cases, we have small punctures in a concrete wall, which are these sort of window boxes. And these window boxes we wanted to create as sort of elegant as possible. So, and as simple as possible in a way. So it's a steel box with two straight sides and two sides that are chamfered. The top side is chamfered so that it allows water to drip down. And the other side is to really visually create a cone effect in from the interior to frame the view more dramatically. I'll show you here from the outside how that looks. And these boxes are placed in plan in certain accesses. So here you actually see through a series of spaces, eventually through an outdoor shower courtyard over here. And then even a small little shotgun window in that shower that looks outside. And here from the inside, you see how that sort of framing, the sort of cut-off pyramid shape emphasizes that view of the surrounding of the tree trunk outside as well. And here from the outside. So this bit more detail. It's maybe a little not so crisp, but it's a steel box, a steel plate. This is also hot dip galvanized, so that there's no maintenance required, no painting required. Then on the inside there's a plywood, which is just simple plywood, which is polished in a small beading putty on the edge. And then on the outside, there's a glazing, again, a galvanized glazing beading putty. And the glass is just fixed in between that. And then we use silicone to seal the gap. And a little hole at the bottom of this glass. So even if there would be some kind of water seepage through this, some sort of crack between the silicone, the water doesn't flow down this plywood and then starts rotting it. It then drips down below. So here you see the detailing. I think eventually we had a trouble with, because we realized that if you would, how we would actually place the glass. fixed along with, was actually fixed before the galvanizing happened. So this whole thing, this whole box goes into a galvanizing bath, and to make sure that the gaps were sealed properly, it was first welded and then hot dip galvanized. But then if you have to put the glazing, you can't normally put the glazing from the outside. So here we actually had to put the glazing first, and then we put the plywood on the inside, but we actually, in reality, kept a little strip at the end, which we later filled up with another piece of wood to fix the glass in place. Here's some other details that we developed together with the carpenters. We wanted a very light railing. This house is not for a house for a family with kids. Otherwise, we couldn't have done this. You would have had to have vertical or horizontal lines at every 150 mm. So this just has timber poles, and we didn't want to see any sort of bracket on the concrete with sort of screws that you could visibly see on the concrete slab. So there's actually a sort of a female threading in the concrete slab. Then there is a sort of a shoe of stainless steel that connects to that threading. And then there's a vertical timber post that is inserted in that steel shoe. And that connects again to the timber frame on this, the stainless steel frame on top. And then the timber railing, the handrail on top. But the span between the timber rail, between the posts is quite large. And the timber itself on its own would have sagged or even cracked if you would have leaned onto it. So there's also hidden steel plates inside the timber rail that's again screwed from below. And then here's some details of the screens that are around. L frames on brackets, and here timber slats that are again connected with steel plates. Again, the steel is all galvanized before, and then from behind it is screwed to prevent these thin vertical strips from bending. Any questions about this?
I have just a small curiosity about that metal box window. So first you open the concrete, so in a sequence of construction, all the boxes insert in the opening and then screwing it, or like how metal plate and concrete join at the.
That's also a very good one, because now remember the issues that we had. We envisaged that if we would make the provision for this window box in the shuttering work, that we would have to pre-make the boxes in a way, because otherwise all these metal boxes had to be of a different size, right?
Yeah.
So we had to make one sort of farmer that is inserted in the shuttering, and that could repeat in other places as well, so that this straight line here and this diagonal line in both section and plan would exactly match in all places.
Yeah.
And now you do see that it actually perfectly matches, right? There's a small silicon joint of about 5 mm again that seals the gap. And it has happened in all places, but actually not because we make that pharma the same. Eventually it still ended up that we had to make these boxes custom for each frame, because somewhere in the pattern work and with the casting, something shifted a little bit here and there, and we had to make it again, the whole box frame, first in plywood, test if it fits properly in the concrete wall, take the measurements, then make it out of steel, test it again, send it to the galvanizing factory, which is about 40 kilometers away, and move it back to site, and then install it.
Yeah, thank you.
Anyone? I think we can move ahead.
Yeah. This is a more recent project. The artist residency in Alibag again. Here you have the city of Mumbai, of course. On the other side of the bay, yeah, you can see it from Bombay. If you're in the tower, you can see the site over there on the shore, and vice versa. You also see through the geography that you've got this sort of hill here on top, and that hill on the west side sort of slopes down gently, but on the east side, yeah, this is an estuary, right? You have a river that flows down, the same river that comes from the site in Karjat, right? Of the first two projects. It reaches the sea here, and all this land here is low-lying lands. It's marshy land, it's mangrove land, and our site, it's specifically is located here. This part of this landscape is a little raised, and the village is also called Bagdanda, which I believe is called, it's Mastering for like a raised garden amongst this, yeah, the sea on this side, and then here paddy fields. Of course, in the past, these paddy fields would have been just marshy land, right? It would have been sea at high tide, and it would have been exposed mud flats during the low tide. But now you see a road, and you see here some small dikes that have been built, and all these little bunds that are built around to convert it into agricultural land. This project is, yeah, it's an artist residency. It's a place where people come together to create art. There's a workshop, and here in this grove here, full of palm trees, is where our site is located. Now, yeah, you see how sort of treacherous this is, right? This with a few inches of sea level rise, or maybe a foot or more in the coming decades, this is likely to be under threat, and so would our site be. And in a way, like even from just a client's point of view or real estate point of view, building anything permanently here would be, yeah, a waste of funds, at least in long term. But yeah, it's also not very sensible to build something here permanently from a sustainability point of view. So we decided that we should build something that sort of respects the landscape and its changing conditions, and it's something that can be actually dismantled. And if it needs to be, maybe it's in 5 years, maybe it's in 10 years, we don't know, maybe it's in 15 years, but it could be dismantled and it can be built up somewhere else, somewhere higher up land, and such that all that sort of energy you put into the designing and the thinking of a building, but also in the making and the material and the embodied energy that you put in such a building hasn't gone to waste. And on top of that, we made this building such that it's raised off the ground. It's raised off the ground. It's built on these boulders that we excavated from a site nearby. There we built another project. Not very unlike this very traditional 19th century amalama, which we which is found, this kind of structure is found in Sri Lanka. They are little rest places, little places, like almost like a bus stand of the 19th century, right? Where pilgrims would come and rest for the day or rest in the night, would be protected from the rain, protected from the sun. And in that case, it's placed strategically on top of a sort of a rock outcrop amongst the paddy fields, then placed on boulders, and then beautifully these timber logs are placed on top of these boulders to level, to make the top of this platform at the right level, right, at a horizontal plane. Because of course the boulder, the rock underneath is not in a nice horizontal surface. And this building is then consisting out of these two pyramidal shaped roofs that are slightly offset from each other on a framework of steel columns that are at a grid of 1.5 meter. And this is a drawing which shows all the elements that have gone into this project. Right, all the steel components. I think this doesn't show. Yeah, it shows the rock as well in scale. They're not all in the same scale, but here there are columns and the rock and then beams, tension rods, bamboos, all the junction elements, kind of emphasizing that this could be, it's like a IKEA puzzle piece and it could be assembled but disassembled as well. I've got here a few photographs of the site during the construction. Again, it's hot dip galvanized, especially here right on the coast. It's even more important. Otherwise, this would corrode within a few years. You see that these beams are all bolted. And it doesn't necessarily mean that it's the most pretty. Like what's much prettier is just a nice I-beam directly connected to a steel column welded neatly. No, if you do it with nuts and bolts, you have to keep margins, spaces, and gaps. You have to have extra insert plates, and it becomes much more messy and complicated in a way. Here you see the assembly. You see the side. This is a piece that you'll see back in the roof design later on. Here, there's another epoxy layer on the steel. These are plates. This is a plate which is for the tension member that keeps the roof in horizontal stability. These are little hooks on which you can hang art. It's also galvanized, right? So it's already pre-taught before the construction, before the thing is assembled. You see how partitions are made. Then the roof assembly. See the bamboo roof. I'll talk about the bamboo roof a little later. But this is essentially like a pyramid-shaped roof with a diagonal bracing of bamboos. And then here, using the finishing stages. So hopefully fast for this. Yeah, here the detail section to the building. Now, these steel columns are placed on boulders, but actually the boulder is cut because of the bad soil condition, there's additional brickwork below the boulders to create sort of a mass. And it's not actually mass necessary for the weight of the building, but it's mass to prevent the building from lifted up during winds. And there are actually cyclones in this area as well. So it's actually sort of mass to keep the building down, And this cut that we make through the rock, a core cut through the rock, is actually to anchor the steel columns into that base of brick below. That you see here in this detail. With that insert plate here below. And you see all the assemblies of little plates that connect those I-beams together. There's a timber deck directly on the steel floor, the columns, and there's a box section on the top. And then horizontal box section that frames it in the other direction. Then you see here an insert plate for the bamboo structure above. And that bamboo structure has timber battens, then bison board that you saw in the previous pictures, and then a layer of bituminous sheeting. And then the gutter for this building is actually a folded plate, a folded steel plate that overlaps with the bison board and gives a little projection and protection of the screens. And a spout, a rainwater spout, is connected at every, I think every 2 or 3 meters or so. You see how that comes together in elevation. This is a wind bracing that prevents the building from tilting sideways. Here you see a very simple detail of timber screen that slides across the wall on the outside of the elevation so that it can open up completely. And at the bottom it's just a timber frame with a wheel that's set on an L angle, and at the top it's just a steel strip on which the timber frame with the groove slides. It's just a sort of a spacer and a distance holder. You see the little spouts here on the facade as well. And then on top you see a skylight. And the skylight has openable windows which are motorized. This allows the hot air that sort of accumulates in this dome, this pyramid-shaped roof, to escape from the top. And the top of these skylights are actually covered with solar panels. The sizing and the framing of the roof is exactly as per the size of, I believe, 4 by 2 numbers of solar panels, so that it fits in perfectly. And these solar panels, of course, get hot. It's eventually just a piece of glass, which heats up the air just below it, which creates a sort of a temperature difference, which then sort of encourages a natural ventilation inside the space. Here you see that from the inside. And you see the skylights again with this overlapping details, aluminum framing. It's storming. I don't know if you can hear it, but it's very heavy here outside. You see the detail through the center of the building with this timber ladder that takes you up to a loft. and these bamboo poles that are in a diagonal fashion supporting the skylight. And then here you see the roof drawing, which is a folded out elevation. So the skylight in the middle, these 4 elevations folded out, and then the front elevation also folded out with the columns and the wind bracing here. These bamboos are placed diagonally because it creates a very stiff framing across the surface of the roof. When something becomes a triangle, it's inherently stable in comparison to when something is placed parallelly and it forms a rectangle. So we use that principle which is in a way also aesthetical, that diagonal framing. It's also a structural element. And you see here how this comes together. Now you also can imagine that then if this happens, all your bamboos are placed in different axes, both in X, Y, and Z direction. Right. So when you have a building which is prefabricated, where everything has to be nut and bolted and nothing can be welded, this means that you need to design a special piece to allow that flexibility. Otherwise, you could just, probably weld a rod into this beam in the right direction, and you can fit a column, a bamboo column or bamboo beam to it. I'll show you that detail again later, but here, just the process of treating as well. Some projects have different timelines and different situations. The previous project where we did bamboo, we used a fumigation method. Here we used a method because we didn't have a fumigation possibility. We drilled holes in the bamboo, and then we filled that up with, We fill that up with a solution of creosote, like a sort of a tar, and then plug that back in with bamboo plugs, kept it for, well, I think it was a week or so. And that's how all the, that's how the bamboo gets its life. The end joints of this bamboo are basically reinforcement rods that has a profile to it, and then this end connection. This is inserted. You see, this is the end connection. This is circular, and it has a plate and it has a hole, which allows you to change or rotate it in the right direction. But after filling, this gets inserted, and then you fill it up with concrete, cement to fix it in place. But then to prevent the bamboo from splitting at the ends, we did this threading around, and this threading has to be done in a very particular way. The rope has to be made first wet, and then you tie it with a lot of strength, so that it really fits in and is not allowed to expand. You see the roof construction again. These timber pieces are, the bamboo of course has different thicknesses and different diameters, so this timber piece actually has again different thicknesses to accommodate the level difference between bamboo and bison board sheets. Eventually we had to actually tie these bamboos together to the main structure, because without this, the whole frame was a bit like acting independently from each other, the bison board as well as these bamboos. So what we did is we created sort of C sections that are puncturing the roof and that are holding the bamboo together and tying it. and the rope is here purely decorative. And here you see then the detail of how that plate that's inserted in the bamboo is rotated, and then the top that sits on top of this beam is also of a similar kind, a circular plate with a vertical plate on top that has holes on the top that can be rotated in all directions. Here are some more plans and elevations sections. Any questions on this?
Anyone has any question?
Shivani may have some questions.
Hi, Robert. No, I don't really have any questions. It was just really nice to see from the context to how the project turned out. So yeah, it was a trip down memory lane for me.
Yes, nice. Any personal stories?
No, it was just how you mentioned the coming together of the prefab elements, and even the bamboo and everything that happened on site, the back and forth during the treatment was yeah, certainly an experience.
The learning process. This is that member that I was talking about on the top of the beam that has these horizontal slots in it. This allows that piece to actually rotate on the beam. And you see them here. Anybody else?
Maybe I think quick, I might tell you, I don't know whether you have questions or not, but it's very interesting when he's showing especially the sequence of construction in which he is dealing with bamboo in particular, because how do you sort of fix that bamboo piece in the sequence becomes important, because you have to ensure that because both the sides of that has a steel cap or a steel shoe, okay, and you need to have a detail that you can easily fit into it. Okay, so that is one thing which I don't know whether you observed it or not. The second thing, most important thing, is to deal with the aberrations in the geometry of the bamboo over the cross section. Okay, and the timber becomes that forgiving tie, which sort of ensures that that industrial material can sit on a natural material, and timber mediates between the two. These other things extremely important to sort of for you to sort of note down. Of course, because in the sequence of construction, again, you can see that the whole steel member is sitting on that bamboo that section. If you look at the top, and then rest of the elements sort of comes in, and so you should think about from a point of view of integrity of the structure, because there's a heavier member which would be coming and sitting on the lighter member. It is quite strong in the plane. The only problem would be out of the plane. How do you tie it? Okay, so little bit of shakiness would what Robert was talking about perhaps is because unless until you don't tie properly the horizontal member, or let's say in this case the inclined member, you won't be it won't be stable. It won't be stable means that because of the ductile quality, ductility of the bamboo, the stiffness of the bamboo is different from the stiffness of the timber, is different from the stiffness of the steel. So now you've got three of these material working together, and so that's why they need certain degree of integrity, either through form or through brace or anything. So that's, I think, very interesting point in a way Robert was sort of making when he was talking about connecting it using a C sort of a, section, etc., or a channel. Yeah, I think that
It's a good point, and I think you've sort of intuitively already understood there's some sort of secret happening in this roof, right? Because you've got a nice stiff plane here, right? That's stiffened by a diagonal in this surface. This top is also quite stiff, right? That's just, again, a folded steel plate with more length, more width on the right because it's a more shallow sloping roof, and lesser width on the left and the sides because it's more steep. This is quite stiff. It's like a ring in horizontal direction, but across this, there's I think this length of this member is 6.5 meters. Just the maximum length that we could get in bamboo in local markets. So what's actually happening in section is, and I don't know if I have a picture of that, of doing the construction, but you see the places where we have those rings, this one here and this one here. There's actually a small box section outside of the bison boards. And then I can show that to you in this section here. Yeah, you see this piece here. That's the box section that sort of ties these bamboos between the two layers, the bottom and the top, again with two more levels.
And the other thing is, this something again, this we need to think, Robert. I'm also not sure, but I'm just opening up for that. To me, perhaps the longer side member is not at all working. It is only the C part, the 6 meter part inclination is not working as much as your other part. So the load distributions are very different because it's such a long sort of load path, and the rest of them are so steep. So
Yes.
so that seems to me almost like a cantilever around other three forms which are much more steeper. In my sense of it, we need to check it on site because it is well integrated, as I'm saying, as a sense.
Yeah, that's right. The horizontal or the gently sleeping slope has a very different challenge in a way, and the challenge there was actually the sagging of the roof, right?
Yeah.
Potential sagging of the roof. So
Yeah.
this
So
do that. This part actually, this member potentially could sag down.
it will sag down. If you are not tied, it is going to sag down.
And
Because
in fact, one of the iterations of our design was to make it sagged, to make it a little curved.
which would be very good. The thing is, that will work with its nature, because see anything more than 1.5 meter in bamboo is going to sag if you are using single bamboo section over a period of time. So this is only retained by form.
Yeah.
Okay, the longer one I'm saying, but the point is, anyway, it's quite an.
I think if it would have been up to us, we would have made it curved, but it became more complex for the contractor that we worked with.
Yeah, but you resolve the problem for the contractor by adding the timber, basically the timber tie, because that has solved most of the problem, because then once you do that, all the aberrations are covered up. So the detailing itself works so well with rest of the thing. The only thing it requires a lot of effort to customize it.
Yeah, absolutely.
Yeah, so I think, should we move now?
Yeah, it's already well, Dutch time, 4 o'clock. I'm happy to continue if you are all keen on seeing more.
How many projects are left?
Let me see. I think I have 3 more projects, but I could choose one. Or I could
Yeah, you
choose-
can choose and maybe quickly show, because otherwise it will seem incomplete.
Yeah.
And maybe in the end, we can have a 5-minute discussion. Yeah.
Okay, this is a project. It's a housing project, a concept for a housing project rather. And yeah, now let me try and be really brief and say it in a way very bluntly. The concept behind this housing project is create a solar farm, and you have a roof, and then you build housing underneath it. And this the energy that you produce through the solar farm, you of course consume, but we've calculated that about 10 times extra energy is produced in a situation like this, which you can sell to the grid to finance the construction of the project. So this is what, you know, is in essence, it could be a regular solar farm, but then with housing underneath. If you build something like this, you need to make sure that, because of course you're trying to make this model that is actually self-financing and self-sustainable. This is not just an architecture project, it is a financing project. It's a financial model, it's a financial innovation. You need to build something like this very efficiently. Because if you don't, you're not able to deliver the promise of making housing affordable. So part of this construction is completely prefabricated. The part that needs to be built so that you can start placing solar panels on top and start producing energy is completely prefabricated. It's like a normal solar farm. Everything else, that's what you see on the screen on the left. These are the elements that go into a house like this. Everything else is customizable and customized or adapted to local conditions. And then there's some off-the-shelf products like a toilet and a tank and a geyser and a pump and wiring. Normally, prefabrication happens in these sort of ultra dense conditions where it's all about time. In our case, it's also about time, but it's here the cost of land and the cost of construction is so high that you can afford big machines, big manufacturing equipment to actually put this all together. If you do this in a rural context like India, you cannot afford that. You actually have to make something that's manufactured in large masses, but that actually also is very small and compact and modular, that can be transported easily and can be built up together without any equipment. So a normal column, which would usually require a machine to be lifted up in place, is actually made out of small modules of 400 mm high, and that are strung around a central rod to combine them together. You see here the elements of a particular section, and you see here a mock-up that we've made of how a column can consist actually out of small pieces and that are strung together on a rod and structurally work in a way like this little toy, right? Compression and tension. And here we did a test of how it actually could be made and how it fits together. So one block weighs, I think, 20 kilo, can be easily lifted by one person. And no equipment. Then on the top of that rod, there's a joint that's tying these blocks together to really create the compression and tension within that rod. Solar panels are put on top of the roof. And this is the prototype we built. I'm just going very quickly because there's not enough time. This is a project that's still about to complete, 99% done. It's built on a hill. Again, in Alibag in this case. And here, this hill is very much exposed to all surrounding villages and roads, and from the sea you can see this hill. So we want to build a home which is very significant size. Anyway, it's about 12,000 square feet. We want to build this home such that it would settle in with the landscape, but we also realized that we wouldn't be able to put off the trick of, let's say, the riparian house. It had to be also a house that in a way is proud and it doesn't shy away from presenting itself. So it's a bit of a combination of both. There's a part that's embedded in the ground, embedded in the hill, and a part, two linear pavilions that are placed in the direction of the view, and therefore with its tall facade facing the view as well. Here you see these two pavilions, two linear roofs, and this entire part here is the footprint of the house. So half of the house is actually underground, but this allows us to kind of break up the scale of the house into two parts, but still have them connected between each other. In this climate, it's hot and it can rain tremendously. You need to be able to have a passage that connects these two parts of the houses. So on the back side, on the sort of arrival side, you arrive there at the house from the top. You see a very gentle, low, single-story house made out of a stone wall and a big opening in between. And you see the other wing here as well. And the rest of the house here is sort of hidden below this roof, this green roof. Oh, sorry. And the other side of the house is very light. It's very vertical, it's very open, it's very transparent, it's very elegant, sitting on the edge of a curved swimming pool with a very generous, tall, but also deep veranda outside of that pool, and big cantilevers to protect that veranda from rain and sun. This is like, yeah, almost like a chapel-like space, but a very light chapel-like space with a screen that wraps around. And then the inside, there's, again, the learning from the riparian house comes back here, where we use steel frames. The detailing is a little different. There's a learning that we made, and we improved this detailing here. But we've also gone scaled up, right? These are very large pieces of glass. This central height is about, I think it was 9 meters. And then at the bottom, it's all sliding windows. It's, I believe, 3 meter high sliding windows of panels of about 2 meter width that all slide along these tracks. And then the roof is like a frame structure with tension cables that are bracing this in all directions. And the interesting moment I feel in this project is where the two come together. That lightness on one side, and then the heaviness, the part that's underground, that's made out of stone, that's made solid, and how that light pavilion sort of sits seemingly on top of that stone wall. This is inside, behind that stone wall. Here we started experimenting. What can we not actually expose this rock that you find, that you excavate, and expose it on the inside? In this case, this rock actually then becomes sort of a seat, an inbuilt seat in this room. On top of that rock, you've got a big retaining wall with a footing that's supporting this vault made out of brick. And here you see the detailing of that waterproofing around, and that punctured pipe that Vivek was asking about, right? How do you make sure water doesn't sort of come and enter this space? Still, despite those measures, though, we have, through the cracks of this rock, water appearing here below, right? It appears here, it appears there. You can see that actually in this construction picture as well. And we were hoping we didn't, but we did get this. And what we did eventually was we created little channels along the junction between the wall and this rock, and as well between the rock and the floor. And for any kind of dripping of water that comes down during the monsoons, drops into these channels and then is taken outside. This is on the exterior facade. You see that this vault is actually supported on a steel beam. And in the space between the lintel on the outside, which is of stone, and that vault, there's a sliding track. And these sliding windows are, steel sliding windows are sliding across that. This is on the outside. Here are these stone lintels that of course do not actually support the wall above. These are fixed with dowels into the steel beam above, but they are giving a gesture of finishing off the stone wall at this large opening. Here on this side, it's a much more structurally genuine sort of design where actually there's a vault or a sort of an arch shape in stone that supports the stone on top. And then on the top of that stone wall, you have a large stone capping stone, coping stone, that protects the wall below, and that separates this wall with the garden above. And the waterproofing membrane goes up against the wall and then turns around underneath that coping stone. Shall I do this one as well? Last one?
Yeah, let's complete it. Yeah.
One house that we're building in the Himalayas, a very different climatic context where, where it snows, where you have a 180-degree view of the Himalayan mountains. Nanda Devi is right here in the middle. And yeah, what's wonderful about this kind of site is that it's so full of history, geological history, deep time history, right? These kind of rocks were that you see are exposed were at some point at the bottom of the ocean, right? In between the landmass of the India islands that came off the giant mass that was at the South Pole and eventually hit Asia and then created this sort of upthrust. And you can see it really play out here, right? This upthrust of the sedimentated rock that juts out, as if it happened yesterday. And then it only made sense for us that when we saw this in this landscape around, that you would build this house out of that stone. Now, practically, there was another reason for that. This part of the Himalayas and many parts of the Himalayas are very difficult to get to. It's a 5-hour drive up the mountains. So can you imagine if you would build in cement or with bricks that have to come from the plains, all these trucks have to bring up that material and you then have to build a house. Unfortunately, that is what happens mostly in the Himalayas. Traditional construction out of stone used to be very prevalent. It doesn't happen anymore. And part of that is because of regulation. You're not actually allowed to build in stone if the stone doesn't come from your own site. If you have to quarry stone from another place and then build a house, then you're not allowed to do that. It's very contradictory in a way. Well, in one way, of course, you protect some mountains, but it also means that the entire construction industry by default becomes unsustainable. And you lose an entire building culture that existed there because the demand for this type of know-how of building stone walls is eroded through this regulation. This is a part of a wall that we built, and it's built out of these men, by these men, which are probably all 50 plus, because these are the only ones that know how to do it and that are still wanting to do it. All the young people, they have moved to different professions or moved outside the villages. And they patiently chip here away on these stones, on these rough stones, and chipping them into place, and then even once it's placed on the wall, it is still dressed and still made to fit perfectly. And this is an example of this building culture. This is an example of a monastery, a cow monastery, right? Built by the British, stone wall and a standing seam roof. And that's just the kind of principle that we built this house as well out of. I won't get into the plan or in the sections, but yeah, this house is built as almost as if it's sort of extruded out of the earth. The rocks are excavated from the site itself and then are dressed and placed on top. And then at some point when it reaches that datum level of the lintels, a steel beam wraps around the entire contour of the house. And on top of that steel beam, then you get a very light timber roof. And that timber roof is cantilevered. It's cantilevered on all the sides to emphasize horizontality, emphasize the view, the horizon of the mountains. It's also curved slightly, so emphasizing even more that sort of panoramic sense of the mountains beyond. And that edge here, of course, has to be super thin, right? Only by making it super thin is how you can make it seem very light. But it actually can't be very thin, or at least the roof can't be very thin because, well, firstly, you need structure. Secondly, you need insulation, and then you need waterproofing details, etc. So now I want to explain how, and then you need gutters as well to take away rainwater. And you need to take away rainwater, not because, well, you could just let it go off the roof, but in this case, in this site, water is scarce, it's on the top of the hill. Anywhere in the Himalayas you'll find that water is scarce on top of the hills. So you need to actually collect that rainwater and harvest it, so you can reuse it again. So this is the edge. You see a timber beam with a capping out of copper. That copper capping protects the pine wood. The pine wood is a local Himalayan pine wood, but it's a softwood. And if you leave a softwood exposed in the rains or in this kind of climate, it will start becoming brown, black, and rot eventually. And this capping prevents the end grain of the wood, which is even more prone to damages over time from becoming wet. This is a mock-up that we made of the gutter. You see that the beam, the timber beam, is actually consisting out of, well, the span between one side and the other side of the building is 6 meters, but with the cantilever, it's totally 9 meters. And you will not be able to get a timber piece out of 9 meters long. So it actually has a joint, this timber piece, it has a wooden joint. And you will also not get very easily the height of this kind of timber beam to span that length. So what we've done is actually the bottom of this timber beam, but the timber beam is also horizontally sliced. There's a part that is below the timber planks and below the cavity where the insulation fits in. And then there are runners on top of that beam, and the runner on top and the beam below are connected with steel bolts, which are 25 centimeters long. And they actually make this bottom and top beam one composite piece, therefore being able to span this length. But at the junction where the steel edge beam of the wall connects with that timber beam, there we don't need that height anymore, and that's where we created a space for a gutter. And that gutter is recessed from the wall so that you don't actually see it on the exterior facade. Here are some pictures of the roof from the top. This roof is then finished in copper standing seam. It's a more durable version of what British used to be doing with the galvanized sheet, because that can of course corrode. Copper is something that can last 300 years. They're thin sheets, I think it's 0.6 mm copper sheets that are folded as trays. Those trays are folded inside the house and then are placed on top of the roofs. And you see these little clips here that are placed at intervals that are folded around that sheet itself. That is placed on top of a bituminous layer. So this bituminous layer is an extra waterproofing, just as a safety factor. And then once you place these trays next to each other, you have this little machine that folds the two layers over each other, along with that little clip. And that little clip keeps the sheets in place attached to the roof. And then at the edge of the roof, that sheet is again turned around into a fold, into a circular plate, circular end capping. And here's some pictures of how the copper is also folded around the members, which are again exposed to the rain, which is the pergola. The bottom is still kept visible, and here you see this on the roof, on the top, curving around the direction of the views. So here it's really a combination of all sorts of different crafts, skills, some skills that are local, that have been existed for centuries, some crafts that exist, like carpentry exists, but not in this kind of scale of this kind of roof. So a lot of learning and teaching between us and the carpenter existed to be able to make these kind of spans. And then the craftsmanship of this kind of standing seam roof that is actually made by a French specialist who has been living in Overburg for the last 20 years, who has built up a local team with that kind of skill to build these kind of roofs in many parts of India. And yeah, that's where I would like to conclude today. And I'm happy to answer some more questions.
Yeah, Robert, can you stop sharing maybe, and then?
Yeah.
You have questions? We started with 44 and we ended with 20, not bad. When it comes to detailing, that's what happens, because it requires that last fight. When nobody is there and you're still fighting to resolve that last bending in the sheet, that will take care of that raindrop.
Exactly.
Well, maybe if you don't have question, I think I felt that there are a lot to learn for all of us. So let me begin by saying that this was a presentation that was quite attentive to the detail in its true sense, not only in terms of its visual quality, but trying to explain the rationale of how things are put up together. So right from the beginning, if you see in the way in which Robert was trying to explain, there was fair amount of clarity about what is inside, what is outside. So what are the materials that are supposed to respond to the conditions of outside, and what are the materials that are supposed to respond to the condition of inside? Not only that, further to that, if you look at the way he explained the section, he was very careful about explaining which materials should touch which and which materials should not touch each other. What it means is that that not only there's an awareness about the properties of the material which we need to learn, but also about how compatible and incompatible properties of material come together, and how do they respond to inside and outside environment. There were some explorations which he showed in quite detail. If you look at it, some of the early explorations when he was trying to show for you, he explained part by part. Okay, he sort of went ahead and explained to you in a way for you to visualize both exposing the problem of construction in the process of sequence, but also to think about the construction itself. Okay, so while, let's say, discussion on how you box a sort of a metal container into a concrete, or how do you lift through a rod a channel section and allow the bamboo strings to sort of fit into it, or how do you work out, let's say a material which is much forgiving in relationship to the material which is much more stiff in the sense that it is less forgiving. Well, while in the beginning he did say that he will be focusing a lot on details, but he was very crafty in telling us the story as well. So I don't think that we missed the part of or let's say we missed too much of the story that was behind each of this building in the way it was thought for, right from the siting to sort of the way it developed. There was also particularity in the way drawings were done. So if you look at it, there was a discipline of putting up the drawing. In all the drawings through the exos, through these axonometric drawings, he clarified for you how the building is sitting in the landscape. Okay, it was fundamentally very sort of clear about that. He also sort of went ahead in quite detail to sort of connect the question of detailing from the point of view of economics of the resource to how high you can go. So that from the project in which the solar panels were used, and the economy of the construction and the sheer ingenuity with which these details were sort of coming up together to sort of I would not say very high end, but yeah, very thoughtful sort of work in terms of use of resources. We also came across saying that the detailing does not mean use excess resource. Detailing does not mean that that there is an endless sort of palette available resources to sort of use wherever you want. But given the economic and the financial constraints of it, what appropriately sort of can be done, I think it was very clearly demonstrated in various scales of the project. So, so I felt that uh, you know. I think this was something where somebody directly gave you the learnings. I mean, he was so explicit in that. He was so clear about explaining to it, and also he was fundamentally very clear about that you need to ask questions. Okay, so I think it's a beautiful sort of ending to this 5 intense days of remarkable practitioners uh, who have shown you different ways to look at detailing. Okay, so from the first when Gopal was trying to explain to you how a furniture, when they are sort of trying to produce it, is looked at from a point of view of a universal knowledge, universal material that can be made everywhere, which was quite interesting. To the second talk where Girish tried and showed you through one of the innovation in the way sort of making concrete walls, one of the innovation that how important it is sometimes to look at detail which otherwise is not seen and is only there in the process but is lost as a visual entity. So many things in detailing are not visual; they are inside, and only when somebody is trying to explain to us the process, that is what is sort of quite visible. The third lecture, which we sort of went ahead, where uh, where we saw this guy.
Samir.
No, Zamir. Yeah, so Zamir was again beautiful because he was interested in detailing, but he was also interested in questioning it, and a lot of questioning came from the narrative itself. Okay, and fundamentally in the way in which he explained his learning of probing into history, doing research, and trying to build up sub layers into this question of detailing, and not look at detailing only as something which is physically coming, but it is more layered in terms of stories that the architect or the designer is trying to put up, brought a very different dimension to sort of the detailing. The fourth lecture, which was by Samuel, was again a very interesting take on the nature of collaboration in contemporary Indian practices, where fundamentally he sort of clarified that the way he was engaging with various skills, artisans, and the way he was trying to sort of curate it to get the work with this larger idea that, or this acknowledgement of the fact that architecture is by far a sort of a community work, and it requires a sort of a great amount of give and take in order to sort of build something of this kind. He also further was instrument in trying to think about putting many of the craft traditions sort of into a palette of detail, okay, and which he is sort of continuing to do. He in a way also hinted towards how can architecture be enterprising, and how do you break up the component of the practice into something furniture which is like something which is running in a different scale, whereas architecture trying to explore some other nooks and crannies of the profession. And then we have this end talk where Robert explains detailing in the most vivid way, both in terms of the logic of the construction, but also in terms of its scientific learning. In fact, there aren't a lot of examples of people where you see a detailing which is coming, which generally we are used to seeing in sort of say European traditions where you're dealing with climate of a very different kind, where the diurnal variations are very different. In India and in all parts of the tropics, we don't layer too much. Either we work with the thermal mass most of the time or look at building as a pavilion, because in between is something which we have never explored. And if you look at it, that in between he has brought in while working in the tropics. Okay, so I felt that it was a fitting end to this fourth session of the Straight Talk series on detailing. So Robert, you want to say something? Otherwise, thanks. It was wonderful.
Well, thank you. Yeah, I think you summarized it well. And I just realized that I haven't spoken about the title of my lecture yet.
Oh, that was beautiful. That made me smile. That made you Indian.
I mean, this is probably the first thing that I heard when I went on a site in India. Unees-Bees. And my father is a carpenter, right, from tradition. And he eventually became a teacher in carpentry. And in my childhood, I would already go with him like to his school in summer holidays, and like he would make a cupboard or something for the house or a bed, and I would make a little chair, right? And then one thing that he would say is mate is weten, like when you measure, you know, right? You always have to measure. And the other thing is also a Dutch version of Unees-Bees, which is gelijk is ongelijk, which means if you try to make it fit perfectly, it's not going to fit perfectly. Nothing will ever be straight, right? If you try to make something match, align, it is not going to align. And that's what immediately connected with me when the carpenter said Unees-Bees, 1920. That but it will be almost correct. But there's also, of course, another. So the story is that you should never try to make it perfect, because if you try to make it perfect, it will be even more glaringly imperfect and mistakenly be imperfect, right? But it also has a story about ambition, right? It also can be interpreted about, well, I know you want something perfect, but be like, we'll just do whatever we can or want to do it at the day that we're doing it, right? And that's also about, eventually about collaboration and about motivation, about getting people aligned to make something together that and make people proud of what they are doing, right? So that you still get sort of an end result that is as much as 2020 or Bees as you can.
Wonderful. So maybe see you soon in the campus. Let's see how
Yes,
we can.
I would love to. And wish you all the best with your modules, and in the future, if you have any questions or something comes up after going back home and you're thinking, you're always free to send us an email, and we're happy to respond.
Yeah. Thanks a lot. I'll anyway contact you, Robert. I'm putting up a book for which I'm putting up some of the case studies in bamboo construction. So I'll put up that as one of the. So I'm just putting up case studies from India, because I don't want to put up across the world. So I'll contact you for that. Okay.
Okay, fantastic. See you then.
Yeah, thanks a lot. Take care. Bye.
So late.
Bye, Robert. Thank you for the talk.
Bye,
Good
Shivani.
seeing you.